80 years from now, future generations flipping through old family photos from a vacation in the Maldives. But instead of basking in the beauty of sandy beaches and crystal clear waters, they're studying those images like a history lesson. Scenes of an ancient city submerged beneath the ocean, much like Atlantis. This haunting possibility isn't far-fetched. By the year 2100, the Maldives could be completely underwater. The government has already declared that 80% of its islands are just 1 meter above sea level. And it's not just the Maldives. Around the world, rising sea levels are posing an urgent threat to coastal communities, cities, and entire nations. But why is this happening, and what does it mean for the future of our planet? The rapid melting of glaciers. It's astonishing to learn that glaciers are melting at an unprecedented rate, 4 centimeters per year. That's 10 times faster than just 30 years ago. This rapid melting resembles what scientists call an anomalous termination of the moderate ice age we're still in. Yes, you heard that right. We're technically still experiencing an ice age, but it's rapidly coming to an end. This leads us to a disturbing discovery. There's more at play here than human-induced climate change. A mysterious factor is accelerating the process beyond what we can control. Scientists are scrambling to understand what exactly this is, but one thing's for sure, we're not in full control of it. Let's take a quick step back to the history of ice ages and how oxygen played a crucial role in shaping the Earth's past. Over millions of years, levels of carbon dioxide, methane, and, yes, oxygen have influenced Earth's climate. When oxygen levels were lower, glaciers expanded, and when they were higher, they receded. But what we're seeing now is a rapid shift beyond just natural fluctuations. The rate at which glaciers are melting today points towards something much more alarming. Entire ice sheets breaking apart, sea levels rising, and ecosystems being dramatically affected. This is the reality we're facing. Rising temperatures, unpredictable weather patterns, and a surge in natural disasters. These consequences are becoming harder to ignore. Oxygen, the catalyst for an ice age. Around 3 billion years ago, life as we know it took a dramatic turn. Cyanobacteria, those tiny single-celled organisms, started producing oxygen through a process called photosynthesis. The oxygen they were creating had an enormous impact on Earth's atmosphere. But here's where things get interesting and a bit unsettling. Oxygen didn't simply support life. It triggered a catastrophic chain reaction that changed the planet forever. As oxygen levels rose, it began to interact with methane, a greenhouse gas that was much more powerful than what we're familiar with today, 10,000 times stronger. Back then, methane was the main driver of the greenhouse effect, helping to trap heat in the atmosphere and keep Earth warm. However, as oxygen increased, methane started breaking down into simpler gases like carbon dioxide and water. This weakened the greenhouse effect, causing the Earth to cool dramatically. And when the Earth cools, things get serious. The result? A super powerful cooling period known as the Huronian Ice Age. For 300 million years, Earth was encased in ice, freezing over oceans and landscapes alike. Imagine a barren world. No plants, no animals, just a deadly grip of ice that made survival nearly impossible. At one point, it's estimated that only a select few, possibly thousands out of a global population of 9 billion, managed to endure. Is how the very oxygen that sustained life began to disappear. Cyanobacteria couldn't survive in freezing temperatures, and without them, the oxygen supply dwindled. It's almost paradoxical. Something essential for life turned into a force that threatened to destroy it. But Earth wasn't done shaping its extreme cycles. After the Huronian Ice Age, a different kind of warming took over, triggering another catastrophic period. This time, it was volcanic activity on a massive scale that released vast amounts of greenhouse gases like carbon dioxide into the atmosphere. Volcanoes effectively reversed the icy grip and brought about a cycle of thawing and freezing, an endless loop of extreme temperatures. This loop wasn't just limited to a single event. It became a repetitive pattern throughout Earth's history. One moment, Earth would be trapped in a deep freeze, only to be followed by a dramatic warming as volcanic eruptions unleashed greenhouse gases back into the atmosphere. It was a brutal tug of war between ice and heat, with life caught in the middle, fighting to adapt. As we face climate change today, this ancient lesson serves as a stark reminder of the power of natural processes. While modern science has given us tools to predict and mitigate some of these changes, the basic principles remain the same. The balance of gases in our atmosphere can tip the scales from warmth to ice in ways that seem unimaginable. The Permian-Triassic extinction, a wake-up call. The Permian-Triassic extinction, also known as the Great Dying. Fast forward to 251 million years ago, this wasn't just the end for a few species, it wiped out a staggering 96% of all life on Earth. Yep, nearly every species we know today was wiped from existence, and it only took a rise in temperature of about 6 degrees Celsius to set the stage for this mass extinction. But what made things worse was a significant drop in oxygen, causing oceans to turn toxic. Life couldn't survive, and the planet entered one of its darkest periods. Now, you might be wondering, we're already seeing a 1 degree Celsius rise in average global temperatures, and we're not stopping there. We're only 5 degrees away from a global catastrophe. Scientists estimate that the current pace of temperature rise is 100 times faster than during any of those historical extinction events. So, how did we get here? What's driving this acceleration in temperature rise? Well, it's not just about what's happening on the surface of Earth anymore. Scientists are looking beyond our planet, exploring the idea that cosmic forces, yes, space itself, could be playing a significant role in this rapid change. Let's talk about the possibility of galactic shifts influencing our climate, specifically, the orbit of our solar system around the Milky Way galaxy. Every 135 million years, our solar system passes through dense galactic spiral arms. During these crossings, cosmic radiation increases significantly, leading to more ionization in our atmosphere. This process causes the formation of reflective clouds that bounce sunlight back into space, cooling the planet down. Interestingly, this has coincided with past ice ages and periods of cooling. While space might cool things temporarily, Earth systems are pushing back with their energy, and it's creating a double whammy of rapid climate change. If it were just one factor, it might be easier to manage, but when you combine natural and cosmic influences, the pace becomes almost unstoppable. The Permian-Triassic extinction serves as a wake-up call for us. It reminds us how delicate our planet's balance is, and how easily it can be tipped into disaster. Today, we're on the edge of history repeating itself, not due to some distant event, but because of the cumulative effects of modern human activities and natural forces. The oceans, forests, and wildlife that depend on stable conditions are already showing signs of strain. Coral reefs are bleaching, polar ice caps are melting, and extreme weather events are becoming more frequent. The clock is ticking, and we're running out of time to make a real difference. The mysterious factor we can't control. Back on Earth, researchers have uncovered a terrifying new factor, methane. While we associate methane with climate change, it's much more dangerous than we previously thought. Methane has been linked to multiple mass extinction events in Earth's past. It's 34 times more potent than carbon dioxide when it comes to warming the atmosphere. What's alarming is the sudden surge of methane emissions. By the late 1980s, industrial emissions were significantly controlled, but a sharp rise was detected in 2006, and it hasn't stopped. This rapid increase has been gaining momentum year after year. Methane, the time bomb beneath our feet. In recent years, reports of massive methane explosions have been surfacing. Permafrost in the Arctic is thawing, releasing massive amounts of frozen methane that have been trapped for millennia. In Alaska, a lake the size of 20 football fields formed in just 50 years due to this enhanced greenhouse effect. And it's not just in the Arctic. Wetlands in Africa, livestock farms in tropical regions, and even landfills near megacities are all contributing to this growing crisis. Methane's ability to release from the ocean floor could accelerate at any moment. Just a 1 degree Celsius rise in ocean temperature could unleash billions of tons of this deadly gas, accelerating the greenhouse effect beyond what we can currently imagine. What does this mean for the future? Today, we're witnessing unprecedented natural disasters, droughts, floods, hurricanes, and extreme temperatures. Europe has turned into a desert while Pakistan faces floods. Florida had its deadliest hurricane in history, costing billions in damages. The polar vortices are breaking apart, unleashing freezing air down south. It's not just warming. Global warming is capable of unleashing extreme cold as well. And as methane continues to rise, we are entering uncharted territory. Thanks for watching. Please like the video, press the subscribe button, and also drop your thoughts in the comment section.